If you have, everybody should have, otherwise, right? Except me. But anyway, so especially for you guys, because I believe most of you guys are in the senior year, your graduates very soon. Okay, please contact your advisor to make sure you can follow your plan when graduates on time. So it's very important because there's something you have to pay attention. For example, the WE/WD requirements. You all know WE/WD, right? So you will need to have at least 2 writing enrichment courses, at least 1 writing discipline. One thing you should know that WD can replace WE. For example, if you have 3 WD classes, you satisfy the requirements. But if you only have 3 WE courses, you still need an additional WD course. So remember that. Another trick you should know that those WD courses you can take outside of school business. For example, you still need 1 WD. There's no course is WD left. You can take like history department or geography department. If they have WD course, it can satisfy your requirement. You don't need to take in the school business. You need to know that. I hope you already know that because you are in the senior year. But if you don't know, check your DAS and talk about with your advisor. It's very important. I will schedule lots of appointments today and the rest of the week with my advisor. Okay. Any questions, comments before we move on to chapter 13? It's good? Okay. Okay. So last class, we spent almost a whole class online, only 5 slides. Right? EPQ model. Right? EPQ model is the economic production quantity. Okay, this will determine the optimal production quantity for manufacturing if the manufacturer want to plan as optimal as possible. Here is the most important graph to demonstrate the EPQ model. Right? There's 2 lines in this graph. The first one is our decision variable, which is a QP, production quantity. So this QP, ideally we should get the optimum QP, which will minimize our total cost. The solid black line is the inventory level. As we have discussed, the reason QP is higher than the maximum inventory level is that when we produce, at the same time we also use our production. So that's why maximum inventory level is determined by the difference between the production rates and the usage rates. And the slope of this inventory line is it's not the slope. So this value is QP divided by P, which is how many days you will continue to produce. So that's we do spend probably 40 minutes or 30 minutes on Monday's class. Any questions on the formula of total cost function? Any questions before we can move on? Question?
What is the IMAX again?
It's maximum inventory level.
So that's just like at the beginning of the ordering cycle or something like that?
IMAX, you can see from this picture, right? It's here. Okay. It's your maximum inventory level because the thing about the area inventory is IMAX divided by 2, right? Because from 0 to IMAX and then from IMAX to 0. So the average inventory level is IMAX divided by 2. That's why it's IMAX divided by 2 times holding cost is your total carrying cost. But the tricky part is to calculate IMAX because in EOQ, if you still remember last week, EOQ is very simple. It's Q divided by 2, because Q is the maximum inventory. But EPQ, Q is not the maximum inventory because, well, we explained, right? The usage rates and the production rates. And we calculate the maximum inventory, IMAX, by this formula. Any other questions? No? Okay. This slide is just very simple. Right? That's the formula for EPQ. Well, this didn't explain how we get, but you understand. It's the same thing, right? Take the first derivative of this function, total cost function, right? This function, you can think about, if we write this function, it's a function of q. It's tc equal to qp over p minus u times h divided by 2 plus d over q times s. If we know all other parameters p, u, h, s, d, if we know all the parameters, it's in fact a function of q. Agree? It's a function of q. No matter whether it looks complex or not, it's a function of q. For a function of q, we can definitely take the derivative. So tc is a function of q. We take the derivative equal to 0. We solve this equation. We solve this equation, and then we get q equal to here 2ds divided by h square root p minus u. So first term, 2ds divided by h square root. Is this looks familiar for you?
Quantity of operation.
EOQ, right? Economic order quantity, right? As Branko said, this is the same formula as we have used to calculate optimal order quantity if you are in the retainer position or distributor position. But now there's another parameter or rather term here, because now we are determining production quantity. So it's p divided by p minus u square root. So that's the only difference is here, in fact. Right? The first one, you are very familiar with that, same as EOQ. But second, we should consider the production rates and the usage rates. Well, we don't have to go through these steps. Okay, how do you solve the first derivative equal to 0? But you understand. The function of q, take the first derivative equal to 0, you solve the equation. Question, comments before we can move on to the example. Clear? JJ? Clear? Okay. Example. Then you can understand how to guess that. Right? Again, I can guarantee you in the exam too, you will see the problem from EPQ. So that's why we definitely should pay attention to that problem, right? A toy manufacturer used 48,000 ruble wheels per year for its popular dump truck series. The firms make its own wheels, which it can produce at a rate, so the production rate of 800 per day. And then the toy trucks are assembled uniformly over the entire year. Carrying cost is $4 per wheel per year. Setup cost, setup for production. Setup cost is $45 for production run. And it operates 240 days per year. And the first question is EPQ, optimal run size. So it's the optimal production quantity. And then calculate the minimal total annual cost. You still remember, or it's already give here. Yeah. So here is Imax, right? So Imax equal to QP divided by P minus U. Right. And this is total cost function. So you plug in, that's your gas part B. And C, calculate cycle time. What does that cycle time mean? For optimal run size. What does that cycle time mean?
It's like
Cycle time.
the time between products.
Times.
The time between the make the product.
Yeah, time between two production. So if we see this graph, you will see what is cycle time here. Pretty clear, right? What is cycle? From here to which point?
Max inventory.
Maximum inventory?
Or
No,
just
no,
from
no.
there to there.
Yeah.
To 0 again, right? So it's a cycle. If we know that's for forecast, or wheel cycle. So you can see it's in fact the time between two production, right? We begin production, begins again. So it's a cycle time. You can calculate in different. So you can calculate the time between inventory becomes 0. It's also the cycle time. The same. Yeah, it depends on your calculation. Okay, the last question is runtime. What does runtime mean? Runtime.
Like
Okay, still come back to the picture. Graph. What is runtime here?
How long it takes to get to back
To what?
there?
To
Max.
IMAX, right? Yeah. It's how long you make the production, right? You produce until the end of here, and then you stop production. The same as Branko said, when you reach the IMAX. The time you reach IMAX is the time you stop production, right? So it's how long you will run this machine to produce. Okay, that's runtime. Okay, before we can do this problem, okay, we have to figure out so many different parameters. The first parameter we have to figure out is D. What is D here?
D.
D.
48,000.
48,000. Great. It's the demand, right? This is annual demand 48,000. What about S? Who can tell me?
S is 4.
S is 4.
I think so. H is,
Good guess.
H is 4.
Yeah, this is 45, isn't it?
S is the setup cost.
Yeah,
right?
it,
S is setup cost. Well, it can be confusing because we use the same S for EOQ, which is the ordering cost. But you understand that S is the one-time cost per time. When you run the machine or you place the order, here is the setup cost, which is, as Jonathan said, $45. Right? What's about H?
4.
4. Everybody understand, right? $4 per wheel per year. Now this part is kind of easy. Then P, production rates.
800.
800? Great. As Christine said, it's 800. You can produce a rate of 800 per day. Okay, the last part, U.
240.
U.
I'm joking.
What does U mean? Usage rates, right? It's also demand rates. How do you guess that? Do we know that
So-
from problem?
48,000 divided by 240.
Great. When you already figure out that, it is not direct given from problem, but we can calculate that pretty easily, right? So we know the annual demand, and we know how many days we operate per year. Then we divide it. That's a ratio which is equal to
200.
200. Right, 200 units per day. Now I believe you get all the information you need to calculate this optimal production quantity, which is part A. Now, please go ahead. I believe you need at least 10 minutes to finish this problem.
Professor.
Mm-hmm.
Well, actually, I was going to ask the sales call. So I'm about to figure it out.
You already know?
Yeah.
Okay. So for question A, it's asking you to calculate the EPQ, optimal run size, same as optimal production size. Thank you. Okay, I've got a different answer of you.
I think my answer
DSH looks okay for me. P. Hey, just double check your calculation. I don't think the number is wrong. But one thing you want to do is first times them together and then finally take the square roots. You don't need to take the square root separately. You do this term times this term, and then take the square roots. Okay? Huh? Not too much.
Are we calculating? It's 48,000 per day.
800 per day is the production rate, right? 48,000 is the demand. Why guys did not? Okay, it's 1,200. My suggestion, which is my suggestion, you multiply these two, then finally take the square roots. Try to separate. Yeah, if you want to think about it, you take the square roots probably as decimal number, that's your base sum. How do you say? Accuracy. You probably want to first multiply them and then take the square roots. Oh. 800 per day, right?
I think 70 is at 48,000.
Even the better part is this. You don't take 1.33 times 800 divided by 600. You don't want to get any decimal number until the final step take the square root. Probably you guys the same. You are very close with my answer, right?
So if multiply by
800 divided by 600. And then take the square root. $2,400.
Okay, I got
Right?
15.
So divided by what? 1? H is 1.
so
What's value of H?
12.
Is 1. The answer is 1.
2 is 48.
Should be very close to 1,200. No clue?
Yes,
got it?
it.
Oh, great. Then second part, use the formula here to calculate total cost.
QP is 400. That's what you saw. The formula up the top.
Yeah,
Top one.
yeah.
Times 600, you get your max, and you gotta put that into the total cost formula. What exactly is Q?
QP is a production quantity. It's optimum production quantity.
Okay.
Yeah. So you think about that. EOQ have QO. It seems like Q0, but if QO is optimum order quantity. Yeah, QP is production quantity. Okay, see that? I know it's can be very confusing, but you think about Q, just a quantity. That's easy to understand. Very close. I guess 1,200 we have this because then we can take the square roots for the last. So first times these two together. I even didn't have 1.33. I times them together divided by 600. This 800 divided by 600. And then final step take square roots. You probably will guess 1,200. Try this. Yeah, because you lose some accuracy when you first take it.
okay.
Total cost. Minimum total.
Yeah, I know you probably will. In fact, it's really 1,200. I got this number. How to get this number? You times these two before you take the square roots. Because it can combine, right? Because both of them will take the square roots later. Times them two. You don't take this decimal number. You just direct times 800 divided by 600. You are just integer. It's like
You divide by
1.33.
2 times
And then take the square roots. Try this one.
800 over
You just multiply the size of
Yeah.
the square root of the
Yeah,
total.
later.
Okay. You said that for a couple of days, right? There you go.
Yeah, let's check the parameters and plug it in. Alright.
I got like that for the Q.
Yeah.
This is really close.
Really close, but why you guys didn't get
Yeah,
1,000?
let's see. That's
Okay.
pretty good.
When you do the calculation, the first part should be 1,200. Guys, give you the answer. It's 1,200 for the right side. Many students guess like 1,199.999. Why you didn't guess 1,200? The reason is that many students really follow this formula. Okay, calculate the first term, take the square roots, and times the second term, take the square roots. You should, the way you can guess that, if you first multiply these two terms, and then take the square root for the last step, you should guess 1,200.
I see.
Okay, you just plug all the number in. 2ds times p divided by h times p minus u. Guess this number and take the square roots. You should guess 1,200. So, my suggestion, take the square roots as the last step. First, multiply these two terms. You should guess 1,200. It's clear? Try this way.
Is the Q when is D over Q on the top one? Is that QP?
Yeah, QP.
Yeah. Okay.
Yeah, here's QP.
I was about to say.
Yeah. You guys 1,200?
Yeah, for A, yeah.
That's great.
For B, for me.
For B, my answer is 3,600.
Just like a problem.
What's the same?
It was, yeah, it's
both
good.
doesn't sound right.
Well needed vacation from.
Okay, first guess the same answer, then ask me.
Yeah, I didn't really
guys.
do-
But probably
do that much.
I'm not correct answer.
Let
Let me double check your process. Okay. MX 900. Yes, I also guess 900.
I put in
Go easy.
full cost, 900, holding cost of 4,
That's right.
plus 4,800 to minimum, 200.
200.
Yeah.
It's supposed to be 12.
Yeah, but they're okay.
So, I didn't do the IMAX. Well, you could still.
It's in my last finance class I'm taking.
Okay, welcome.
So,
What about you?
I'm going back to with Joe because I messed up. I didn't do my IMAX equation right, so I just used the 48,000 and started. I just did the total cost thing.
Yeah, you just plug them in. Okay. You just plug them in. And then you need to write the formula, otherwise we can't double check how can you make mistake. Okay, just write the formula.
Yeah, I got that.
Okay, great. Nice work. Mm-hmm. No, it's not right.
Where did I mess up?
Well, let's see. What is this? 800?
Yeah.
800. Okay. Okay. So it's 402. That's correct, but yeah, I don't know. That seems correct. Yeah. Calculation. It seems the number you plug in are correct.
Right. This is my calculation. Okay.
So IMAX is just QP divided by P times P minus U.
Just be very careful for part B. There's nothing tricky after you solve part A, right? Just plug in.
1,200.
No. Yeah. I didn't get your answer, so I don't know whether the first part is actually correct. At least I have the same results with me. Yeah, maybe I'm wrong. Horrible, right? Faculty make mistake.
One side divided by the
That's great. Good job. You used to do it.
For C, is it
Cycle time. Cycle time is the time between
so
two
you multiply
productions.
total quantity by.
So when you will begin your production, okay, let's say you begin production this month, right? What's the next time you begin production? The next month is that's 7 months. You need to calculate the time between two productions. because we know the production comes from Ferrari. Production run for like 2 or 3 days stop, and then just consume the
Divide by
until it becomes 0 again. We make more production.
That's the usage rate. What do you, or do you, 4,800, I mean 48,000, divided by 240.
Some student already begin the part C. Okay, part C refer to this graph. Here is the answer part C. The cycle time, right? It's from the 0 to 0 inventory. You can consider it this way, or when you will run another production. Okay, if this is Monday, that's another Monday, that means 7 days. You have to calculate. How to calculate that? That's easy. You need to figure out how to guess these days.
Can you go back to the question?
Part C.
Can you go back to the question?
Sure. Go back to the slide.
Okay, sure.
That's all right.
I thought it was 2 8, that would be up there. You just use that answer. Why you got it?
Where's 8 come from?
You.
It seems it's not a lecture session, it's a help session. Yeah, that's correct.
So we're not supposed to have Q times P. It's just Q. That's what they mean.
Anybody guys pass C down?
Yeah, I don't know about you.
Great.
Yeah, I had it at first right now.
Think about it. Runtime. Runtime is how many days you run the machine. How many days you run the machine per cycle? For example, you produce from, let's say, Monday, and then you next begin on Sunday.
240 divided by 6.
No. Think about it, okay. I mean, that's cycle time, you know, that's 6 days, right? 6 days cycle time. But you won't run the machine for 6 days. Because if you run the 6 days for machine, that's too long, right? You don't need to run for the whole 6 days.
Okay.
But how many days you need to run the machine? Your production quantity is QP, right? You will produce up to QP. You will guess you pass A. Then, how many days you need to run until you produce up to QP? That's the question for pass D.
Okay. So it's got to do something with the 6.
So it's 6, not 60.
Well, you mean pass C?
Yeah.
C, yeah, 6 is the correct answer.
Wait, 60?
6.
6, okay.
Who got 60? I want to see who got 60.
How'd you get 6?
Take the,
How'd you get 6 though?
more run size per day.
I got 60 by doing
Divided by the
48,000
usage, which is
divided by the 800 that you
48,000 divided
produce
by
per day.
240 days.
Which is
48,000 divided by 800.
Right.
1,200.
That, yeah, that's give you 16, but which means 48,000 divided by 800, which means how many days you have to run the machine for a year?
right, but you wouldn't operate.
Yeah. But don't make it too common. Pass C is pretty straightforward. Just one ratio. A number divided by another number, you'll get
The number from A, which is 1,200. And you divide it by the usage rate, which is 200.
It's again my elementary school math, so but to figure out the formula used is also elementary school. So it's also fine. I'm pretty sure about that. I will still give you some time. So it's good to see our students explore the brain as much as possible. D, great, JJ. Absolutely correct.
Okay, so
Yeah, correct.
you set up C. Is it
That's
the
what I
bottom?
was just about to
Yeah.
Okay, you
I
start
think
here.
it's the
Oh,
bottom.
you see. 125 is fine because you don't have to run up because the reason is machine. You can still
Since I was saying
half of it, right? You don't have to.
So for C, is it the IMAX formula?
It,
You can get one of the same thing.
C, we have introduced any formula. Yeah, but we introduced after this example. But you can easily figure out the formula use C yourself.
Okay.
One size.
So it equals.
You guys pass D? Yeah,
Which is
great.
what?
That's
Optimal.
great. D is not correct.
It's not correct.
In fact, The formula is correct. 1,200 hours. How do you guys read it?
I don't know.
You don't know. Look at the number. You don't need the calculator. You can tell yourself. It's wrong, right?
Yeah. I don't know why I did that.
Okay, we do have many students have successfully finished this question, which is very impressive because it's not an easy question. So let's do that together. I definitely need some volunteer to tell us how to solve this problem step by step. For task A, which is EPQ, QP. Any volunteer can share the calculation with us? Anybody? The first row. I have to assign the yeah, otherwise no volunteer. First row, task A, easy task.
It's 2.
Everybody gets that, right? First row. What's the problem? Your first row. Okay, so how do you guess that? Maybe?
You want the whole equation?
Yeah, definitely. Plug them
The
in.
square root,
2 times
2 times 48,000
48,000
times 45,
times 45 divided by
4,
divided by 4 times
it's 800
800
divided by 800
minus.
200.
Great. And then final step, take the square root, which will make sure you guys keep the accuracy. Otherwise, you will lose accuracy if you take the square root separate. What's your final results? Maybe?
1,200.
Great. So it's 1,200. So the optimal production quantity is that's 1,200, which means, okay, you tell your manager, okay, that's our plan. So we'll begin to produce up to 1,200, we stop production. And then we continue to use our inventory. Okay. Task B, second row. Any volunteer in the second row? Christy.
Let's see, 1,200 over 800 times 800 minus 200, which is 600,
So it's 1,200 divided by 800
times 600.
times 800 minus 200, right?
Mhm.
Plus,
Oh, isn't it times 4 over 2? Plus 48 over 12?
yeah, that's correct. Times 4. Times the holding cost plus
48,000 over 1,200
mhm,
times 45.
times 45. And you get
4 over 2.
2.
Yes, 4
Yeah, 4 over 2.
oh, sorry about that. 4 over 2. And you get
3,600.
3,600. So, which means your annual total cost is 3,600. Okay, and we can guarantee it's minimize the annual total cost because we use the EPQ formula to get the optimal production quantity. Okay. Part C, that's a little bit tricky. The third row. Bernard?
1,200 divided by 200
1,200. So it's QP,
divided by your usage.
the usage.
Yeah.
So it's 1,200 divided by 200,
Yeah, 6.
6 days. Okay. Now I need you to explain to the classmates why the cycle time is calculated this way. Why is QP divided by U?
Why is QP divided by U? Because QP is your optimal quantity, right?
Mm-hmm.
So if you like that's your optimal quantity, you want to divide it by how many times you're going to use that quantity during the time from 0 to 0.
That's correct.
Yeah.
Very important point, Braham. You begin from 0. You end with 0.
Yeah.
But all the things you consume is whatever you produce, which is the QP. No matter how long you produce, but you produce QP. And then the denominator is usage rates. Okay. So the amount you produce this cycle divided by the usage rates will determine how long this cycle can be. So the way she calculates it that way. So from 0 to 0, and then the production quantity divided by usage rate, which is the cycle time. Very good. Okay, the last part, part D, the last row. Any volunteer in the last row, part D?
I didn't even get there.
You didn't get that? I can tell you the answer should be 1.5. No? Okay, anybody else can help? Aaron?
You take the optimal run size for
Op-
part A.
QP
Uh-huh.
divided by what?
You divide that
Everything you get is
by the runtime.
The runtime.
Uh-huh. I
We're
mean,
trying to
no, that's fine, the runtime. Okay. You divide that by, what was it?
Production rates, right? So it's QP divided by P, which is
1200 divided by 48.
800. 1.5 days. Okay, Aaron, could you explain to us why the runtime is calculated this way? What is runtime here?
Grade 0.
Green area, right? From this point until the end of this point. Then why you use this formula? QP divided by P.
That 1200, I think is the total amount. He can explain.
Okay, Jack? Great, finally. Explain!
Finally.
So it's all, your runtime is how long it takes you to produce the quantity production rate. So it's all based off of QP. That's why your QP is in your numerator.
Mhm.
And then since you're doing how many you produce and that period, it's how long it takes you to produce that optimal rate. So you're doing your QP divided by P, which will get you the 1200 divided by 800, which is 1.5.
Great.
Which is 1.5 days, right?
That's right. Great. So we have solved all the questions by all of you guys. Any questions or comments on this problem? No, it's easy, right? But now we solve very important question. I can ask all the questions my manager raised. First, I can tell manager, okay, every time when I run the machine, I should produce up to this level, 1,200. I can tell you. But I can guarantee you, if you follow my plan, you have the minimized total cost, $3,600 per year. I can also tell you, okay, the time between two production is 6 days. So if we plan to run Monday, next time we'll run on Sunday. I can also tell you, you only need to run machine 1.5 days and stop. You can switch this machine to handle other production, other products, and then wait for another 4.5 days, and then run it again. So I answer all the questions to determine our production plan, and tell my manager what is the minimized total cost if you follow my plan. Then it's the whole picture here. Now we have finished EOQ model, which solve the problem if you are in the retailer or distributor position to place order. We also get the EPQ model if you are in the manufacturer. I think this is already very powerful, even we are introduce some other models later. But you can see inventory management is really a scientific topic. It's really scientific. We know there's general rules, right? How to keep inventory good, easy cycle counting, ABC rule, but come back to this number. Come back to two basic questions. How much to order? When to place order? How much to produce? When to produce? We need to scientific way. Very careful calculation. But we can definitely answer the questions. Okay, the last model we introduce belong to EOQ, big family, is the quantity discount model. So we know that for many situations, if we order more, we get discounts. Right? If we order more, we'll get like 90%, 95%, some discounts. Right? Then in this situation, we can't miss the last part, purchase cost. Right? Still, carrying cost, Q divided by 2 times H, and then ordering cost, D divided by Q times S. So the first two parts is the same as which model? EOQ model, right? So the same as EOQ model. The only difference is PD, which is the purchase cost. P is the unit price, it's the purchase unit price. D is your demand, right? So it's PD. Since we have a discount, we have to add this into the formula. Now my first question is that, in the EOQ model, if you are the retailer store, right? Example, we have Winsu. Why we only have consider ordering cost and the carry cost? We didn't consider last pass in the EOQ. Why we don't need to consider last pass for EOQ model? We have the purchase cost, right? It should add into the total cost. Have we missed something in our EOQ model? we only consider, not only EOQ, EPQ is the same. We didn't consider purchase cost. Anything wrong? First question, should we include the purchase cost in our total cost? Should we do that? General question.
You said
Should we include the purchase cost?
in your total cost?
Yeah? Should we do that?
I don't know.
Yeah. That's right? It's the cost. Purchase cost is the cost. We should include that. But EOQ or EPQ, let's say EOQ, which is total cost is equal to Q divided by 2 times H times D divided by Q times S. That's no purchase cost. But let's say we added purchase cost here. We didn't add this purchase cost. If you remember EOQ, we say we only consider carrying cost and the ordering cost. Let's say EOQ, we add this purchase cost. In fact, we should. But I will show you we don't need to do that. Will this affect our optimal order quantity Q? Will this affect if we add this in the EOQ? How can we guess the Q? Do you remember? How we calculate the Q? We take the derivative, right? So it's a function of Q. We take the derivative equal to 0 and we solve that. But the EOQ, for the last term, purchase cost, has this to do with anything to do with Q? No. It's a fix, right? Because there's no discounts. P is a unit price. Well, no matter what is the Q value, you order 1 unit per time or you order 1 million units per time, doesn't matter. As long as you demand, we know that's the demand. As long as unit price is given, the last term we take the derivative is equal to 0 because it's not a function of Q. Agree with me? Because last term has nothing to do with Q. That's the reason in EOQ, EPQ, we didn't write this purchase cost in our total cost. We should, but doesn't matter. We have this term a lot. Because when we take the derivative, we want to calculate optimal order quantity, optimal production quantity. The last term, derivative equal to 0. Right? PD, take the derivative, is equal to 0. So it won't affect our calculation at all. So that's the reason to make it simple. When we calculate for EOQ or EPQ, the total cost function, we don't add this purchase cost. Ideally speaking, definitely, purchase cost is a big important part for the total cost. But we understand it won't affect our results. It's clear for everyone? Clear? Now, a question back. Why in the quantity discount model we have to add the purchase cost? Why?
Because we're not taking the derivative.
No, Brandon, we are still taking derivative to calculate. But now, does PD affects or related to the Q?
Yeah, because it's based off of how many you order.
That's right. Because P is in fact a function of Q. The unit price is dependent on your order quantity. That's a discount. You order more, you have a lower P. So now, P is not a fixed value. P is a function of Q. That's the reason we have to consider purchase cost. Clear for everyone? Clear? Okay. Okay. We will not go to a formula or example to do that. Please look at your textbook because we can't afford another like 40 minutes for this morning. But general idea is here, right? So if the P is fixed, okay, it does not change the EOQ. So how do you handle the discount model? Is that for every P for the range of the purchase quantity Q, that's we draw this picture or calculate total cost function to calculate the EOQ. And then we compare the EOQ. For example, this is from the page 573 to 576. Okay, so Chicago Surgical Supply Company. So they have this quantity discount model. If you order quantities less than 45 units per time, your purchase cost is $2 per unit. If you order between 45 and 70, your purchase cost is $1.7. Right? If you order more than 17, you get the purchase cost per unit is $1.4 per unit. Okay, that we need to calculate. We need to figure out what is the optimal order quantity. Now we can't directly use EOQ because for different range, the P is different. right? What we can do is that we write 3 different EOQ, right? The first EOQ is when Q between 0 and 45. Now we know the purchase rate is P, right? $2. We calculate the EOQ. That's this EOQ is already out of this range, right? And then if it's out of this range, we choose the boundary points. That's the points in this range, right? That's the order quantity. 45 is the order quantity. If you see this curve, 45 is the optimal order quantity, which will minimize our total costs. Agree with me? Because we can't reach this point. This is already out of range. If our range is 0 to 45, from this curve, total cost function, we know, okay, 45 is our best choice. Now we move to another EOQ, 45 to 70. Now since here, the purchase cost is fixed, then we don't need to add this in. Then we can use EOQ to calculate. That's sorry, this is the first curve is here. Okay, it's also boundary, but 45 is the best. The second curve, okay, luckily we have this point in this range. We can get EOQ. The third one do the same thing. Okay, it's also boundary, right? Then the optimal order quantity is 70. Then we get 3 EOQ. We calculate the total cost function for Q1, Q2, Q3. Right? The Q1 is optimal for the range 0 to 45. The Q2 is optimal for the range 45 to 70. And the Q3 is from 17 to infinite. Then we calculate the total cost for Q1, Q2, and Q3. The last step, I ask you guys, how can we determine the optimal order quantity? I calculate 3 total costs, given these 3 different purchase costs. And what's the final step? How can you tell me what is the optimal order quantity?
Average.
And not average, if it's comparison. When these 3 total costs is minimized given their range, right? This is the minimized total cost if you are in the range 0 to 45. Another minimized total cost for Q2 in this range. The third one, I compare these 3 total costs. Which one is lowest? I can guarantee it's the global optimization. Because here is the local optimization. We need to compare 2 other intervals. And then we compare 3 of them. We know, okay, which one is the global optimal.
So you're saying for like total cost, Q1 and Q3 can be higher than Q2, and you know that you want to order within a range and within Q2, right? That's what you're saying?
Close, but not exact. Q1 is the optimal order quantity in this range. Okay, just from this curve, okay. Q1 is P equal to $2, right? Which is the first line, the highest line, total cost function, right? From this curve, who can tell me what is your optimal order quantity? 45. Agree?
Yes.
Why, Jonathan?
Because that's where the graph is initially on that line.
Yeah, because optimal is already higher than 45, right? Ideally, optimal is higher than 45, but you can only, the boundary point is 45. So the lowest cost you can get is 45.
Right.
Right? So, we know that. But you need to calculate that. Definitely. That's you need EOQ. Then the second one, we don't know. We have to calculate. 1.7, which is the range 45 to 70. You know, that's some middle points. Right? The third one, when you order more than 70, what is the optimal order quantity? The lowest curve. 70. How do you guess that?
This is the lowest point.
Yeah, because you can't reach this theoretically optimal order quantity because it's already out of boundary. But you know that the closest point is 70. Now we have this Q1, Q3, but Q2 need to calculate, right? We plug into the total cost function. We calculate them. We compare. You will get the optimal, right? That's the way how that. It's clear?
Yeah.
Still need to spend some time to read the textbook. Okay. See you guys on Friday.